Hello, and welcome to the E3SM data regridding tutorial. My name is Tony Bartoletti, and I will be providing this walkthrough of the regridding guide written substantially by Sterling Baldwin. A copy of this guide should become available to you at the following URL. That would be highlighted here, e3sm.org/resources/documentation/how-to/regridding in good time. I will begin by discussing some topics common to anyone who might be using these tools, such as the required execution environment, the map files employed by the regridding operations, and offer a few words about regridding in general. I will also briefly survey my workspace to demonstrate a layout that allows me to minimize clutter as I conduct the tutorial and to familiarize you with that environment. Then, finally, depending upon which version of this tutorial you may be viewing, we will exercise regridding examples with either atmospheric, land, or the MPAS ocean data. So let's get started. I will come here to the PDF regridding guide on my left and scroll down to Chapter 1. And we talk about the environment setup. As the guide explains, you should first establish an Anaconda environment in which the necessary NCO tools are installed. If you already have a Conda environment you wish to use, you may add the NCO suite of tools with the first command indicated here under Conda. That would be Conda install -c Conda forge NCO. If instead you would like to create a Conda environment that's specific to doing the regridding and only contains the NCO tool suite, the second command should work for you. And as you see, it names a environment called regrid, and I've used that one myself, and that's why if you look at my console window, my command prompt begins with the word regrid. There are also precompiled NCO tools available if you want to go that route. And the URL is up here under the NCO documentation. So at this point, I'd like to talk about regridding in general. Why do we do regridding in the first place? Turns out that, of course, many simulation models exist, and they produce data on different grid types and with different resolutions. In order to conduct side-by-side comparison between simulations or to combine simulation data in conducting forms of secondary analysis, the output must be presented on the same grid. If you have data on two different grids, you will need to convert the data of one into the grid of the other in order to compare or combine them. There are many regridding methods, but the most common are the area averaged and the bilinear methods, which I will describe briefly here. The area averaged method is employed when you are moving from a high resolution grid, the destination, or the source grid here indicated in red, and you want to convert the data into a lower resolution destination grid with larger cells indicated in blue here. The value that you're going to want to obtain for each blue cell is going to come from a variety of smaller source cells, and it will be the cells that are covered by the blue cell, either entirely or in some portion. And the contribution of the source cells corresponds to the fraction of those cells that are covered. So we see here that there will be 4 cells, source cells, that will contribute 100% of their value, or along the periphery we see that there are other source cells that will only contribute a smaller weight of their value, and that weighted average is what is assigned to the destination cell. In contrast, when moving from a coarse resolution, large cells, in this case the red source grid, to a grid that's of finer resolution, the blue destination grid, we consider that each source grid cell, imagine its values to be concentrated at its center, represented by its center point. And then every blue cell that happens to find these four cells, source cells, to be the closest ones, will have its center fall within the bounding box connecting the centers of the source cells. And that each blue cell then is going to receive some value from the four source cells, but in proportion corresponding to how close the center of the blue cell is to those red centers. So we can see in this case that the point P at the center of this destination blue cell will be receiving more weight from the value in this large red cell B than and the least from this one over C over at this end, which is further away. So that is pretty much what I'm going to describe about regridding methods. Now, because there exists a wealth of standard Earth-spanning grids already, regridding is facilitated by map files that are pre-configured to conduct the cell-by-cell weighting of cell contribution from a known grid, source grid, to a known destination grid. These map files are available at this Argonne National Laboratory site. There are scores of them. We won't have to pull those down because I've already got several of them on hand. As you can see here in my console window, there are scores of different source to destination grid transformations that are already available. We will only be using a few of these, of course, in the tutorial. So I might also add that the data that you might want to examine or regrid, there is a wealth of that data, E3SM data published, a wealth of climate model simulation data available at the ESGF ESGF node website here, with a search front end that will allow you to select data sets from different experiments according to a variety of different criteria. I've already downloaded and have available a variety of data that we'll be using for some regridding here. So before I go any further, I'd like to introduce my environment. You see, in my environment is divided into a variety of source directories that are already populated with data for these tutorials, and I will demonstrate these by just looking at a few files from each one. See, we have two directories of atmospheric model data, two of land model data, and two directories of the MPAS ocean data. And you'll be seeing some of that data depending on which video you may be viewing here. So likewise, once the regridding occurs, the output will end up in these different destination directories at the top. There, we can see that they're actually empty by replacing source with dest here. And there's nothing in these directories yet, but they will be populated as the example grid runs occur. So with that, I think it's probably time to launch into the actual regridding examples. All right, so for this version of the tutorial, we will exercise Chapter 2 of the guide, Atmospheric Regridding. We will run and examine 4 regridding examples on the atmospheric model data. The source data resides in these 2 directories, which I'll highlight here on my terminal. They are actually the same data, except that the first one has data from 1850 all the way through 2014. That's 1980 months of data, and the second one only the year 1850, since some of the regridding examples don't require a lot of years in order to demonstrate what they do. The output from these will appear in these 4 directories, which I'll highlight here at the top of my screen. The simple regridding will end up in the top folder here, the 180 by 360. Then the second example will conduct the very same regridding, but only keeping 2 selected variables, and that will end up in the one on the bottom here. And then the remaining examples will do climatologies and time series generation. So, as it may be easier and more accurate to review the commands from the run scripts I've developed compared to the ones that you'll see here on the guide, and probably be easier to see, I think we'll just examine them directly. They're in my scripts directory here, and so if I do a let's see. Should be 4 scripts here, numbered A1 through A4, and they will do the complete regridding, but only for 1850. The regridding are limited to selected variables, again only for 1850. And then the latter 2 runs will be climatology, run on all of the years from 1850 through 2014, and similar operation on looking at time series. So let's take a look at the first script, and we can see how it compares to the guide on the left. So I'll just edit this so you can see it. The inputs to the command line, the tool will be the NC remap tool, and the inputs are the map file, the input and output directories. You'll see why I'm very careful about renaming the output directories in particular. Turns out that for a lot of these regridding operations, the output files have exactly the same name, either as the input file, or even if you conducted different types of regridding. So if you put them in the same directory, they'll clobber each other. It's sort of unfortunate, so you got to be very careful about that. So for this first example, we will simply take the year 1850, all 12 of its months, and we will then do a complete regridding from their native grid, which happens to be NE30 NP4, to the 1 degree by 1 degree, 180 by 360 grid of the globe. Now, for those of you who maybe are not entirely familiar, the NE30 NP4 looks like you surrounded the Earth in a clear plastic cube, drew 30 by 30 lines across each face of the cube, so that there's a total of 900 small squares on each face. And then you shrink wrap that globe down on that cube down onto the Earth, and so those slightly distorted at the corners, of course, those squares then become painted on the surface of the Earth, and that's those are the regions that are measured in the model. And so what we're turning that into is a 180 by 360, which is there's like a longitudinal line for every single degree, and a latitude line from the pole to pole. Again, one for every degree. So let's go ahead and run this. Shouldn't take very long. You may notice that it's doing the output in pairs, because I think it's by default it's using 2 cores to generate each of the outputs. This will take a minute or so, so I'm going to pause the recording for a moment.
This conference will now be recorded.
And we're done. If we want to look at the actual output, it will appear in this regridding directory. So let's do a listing of what is in there. And you notice that it doesn't look any different than the output or the input directory files, except that those are links. But if we look at them in the long listing, you'll see that there's a significant difference. I'll do that later, but they're much, they're going to be different than, for instance, when we do the selected variables. You'll see how much smaller those will turn out to be. So let's go ahead and move on to the inputs for the second script. So so this looks a lot like the script we used for the first run. The difference is that it has an additional variable vars, and these are 2 of the more than 100 variables that exist in the atmospheric model data. So what we'll be doing is the very same regridding, but the files will have all the data taken away except for the sequences for these 2 variables. I think you'll find it also runs much faster. So let's go ahead and run it. And it's all done. And if I do a listing of that output directory, it's the CAM 18360 vars destination directory. Files don't look any different. However, and this will be probably too small for you to see the font, but I want you to, but you'll be able to appreciate the difference, I believe. Here, if we take a look at the difference between the output from the first run and then we do the same thing for the vars output, S with an S, thank you. You'll notice the file names themselves are identical, which I find very annoying, but you have to live with that. But look at the difference in the size. They're actually less than 1% as large as the regridding that was conducted on the over 100 variables that exist in these files. So it's gone from what is this? 1.3 gigabytes to 1.1 or 11, I guess. Yeah, 11 megabytes. It's quite a substantial reduction. So next we will explore the climatology. These are a little bit more complicated. There's more options that are available. Let's go look at the actual script here. Once again, we're only doing two variables, the same ones as previous. We can specify now a start year and an end year if we so choose. There are flags that control the compression on a per variable basis of the output. The case ID is required as a parameter. Is everything up to the sim date portion of the file name, apparently. And there's also a December mode, which needs to be applied. And this is a little bit strange, but most all of the years of data we have begin in January and end in December for each year. However, from a seasonal perspective, the modelers like to think December through February for one season, and then March, April, May for the next season, etc. Which means that if you don't have, for the year 1850, beginning on 1850, if you don't have the December 1849, it complains and gives up. So you need to actually change this value from well, something I can't remember what the name of this is, but it's seasonal, different. Oh, here we go. Seasonally discontinuous December, as opposed to seasonally continuous, I guess. So this will allow it to run. So the command line is merely, in this case, we're now using NC Climo instead of NC Remap. It will do the remapping nevertheless, but also conduct the climatologies on different scales, as you'll see in the output. So let's go ahead and run this. I don't think it takes, well, it does take a minute or so, so I'll probably pause in the middle. It takes about a minute and 10 seconds. So talks a lot, and then I guess it's giving you feedback about what it's intending to do. So I'm going to pause this recording because it does take a while.
This conference will now be recorded.
All right, so that was done. Took a minute and a half this time. And so if we look at our output, it is in the directory Climo up here. What you'll notice about it, it's a little peculiar, is that it put out two files, actually, and then a link, a third file, for each of its the types of output it produces. You'll notice that the first three are for the month of January, Well, the year is 1850 January through 2014 January, so it's the full range of years. But the 01 here indicates that it's for all of the Januaries. Then we do all of the Februaries. In other words, we're looking at the change from year to year of just 1 month of data. So we'll go all the way down through December. And then once we're completed with December, we look at the data in terms of seasons. Where this is, well, starting down here, we have December, January, February, March, April, May, June, July, August, September, October, November. And then finally, 3 files for the annual wrap-ups of the values. So the ones that you see here in blue are just soft links to the one with the longer name. The longer named one is the one that's actually regridded. You see that it has the 180 by 360 in the name. The shorter one is the same climatologies by month, by season, and by year, but on the native grid. So there's really not too much more to say about the climatology, at least not much more than I'm capable. So we'll now look at the final run, and that is the regridded time series. So there's the page from the guide. We'll take a look at the script itself. All right, so once again, we have our input and output directories. The map file is the same map file we've been using. The variables, we're only looking at, again, these 2 variables. We're looking at the entire range of years from 1850 to 2014. The only real difference from the climatology run is this one parameter here, which is the years per file. It's 50, so that means that it's going to do a wrap-up every 50 years of the values. Once again, it does need the case ID as a parameter. And so beyond that, it's the same command line, only the addition of the years per file in the flags variable is the only difference. So let me go ahead and quit this. Now, when I said we'd run all of these, I lied, because this one actually takes a half an hour. I'm not going to rerun it again. The data is already in the destination directory. So let's take a look at that. The time series directory here. Okay, so in this case, what you note is that the data is pulled out into individual files. Let me just put them in one column here. So there are files for one variable. Again, you can see here that it took it in 50-year intervals, since we began with 1850 January and this ends in 1899 December. Then we pick up again in 1900 January through 1949 December, etc. Only the last file is truncated because we don't have 50 years into the in the year beyond the year 2000. And then again, the same layout, except that it's for the other variable. You'll also notice that, as with the climatologies, there's 2 outputs for each section. There is the regridded one and the same wrap-up for the for the variable on the default grid, the original native grid of the model output. So I guess that closes this section. I think I hope you've learned something from all of this. I probably have, and I'm going to leave up this this slide with some information on it for a few seconds in case you want to copy that information out. And you don't have to scroll back through the video to find it. So thank you very much, and I'm going to close this recording.